All right, so today we're going to look at section 2.4, which is reasoning using properties from algebra. Okay, so what we're really going to start to do is write some proofs. Okay, what's going to be somewhat familiar about these proofs is they're all going to be solving algebraic equations. Right? So you guys already know how to do that. We're just going to use some properties and write very formally like how you're solving the equation. So this will kind of get you thinking about how to write a proof a little bit with geometric ideas too. Okay, so a lot of properties we have from algebra have to do with equality of numbers. Okay, and we'll look at a few of these properties right here. Okay, and these are the properties you use when you're solving equations. Add the same number to both sides, subtract the same number from both sides, all those properties. Okay, so A, B, and C can be any real number that you want. It can be positives, negatives, fractions, or decimals. Okay, this is called the addition property of equality. Okay, these are all properties of equality. So I'm not going to write of equality after each property. But this is the addition property of equality. Basically, it says if A is equal to B, you can add the same number to both sides. So A plus C would equal B plus C. When would you do something like that in algebra? Like this. You'd add the same number to both sides to solve that equation. You do plus 2 on each side. Okay, we also have the subtraction property of equality. If A is equal to B, you're allowed to subtract the same number from both sides. Okay, that's called the subtraction property of equality. And when we write some of these down, when we're doing a proof, I'm going to let you abbreviate it a little bit. Like you can abbreviate property, P-R-O-P, prop, that's fine. Okay, the multiplication property of equality. If you start off with A equals B, you can multiply the same number on both sides. Okay, when would you do that? If you had an equation like this. X divided by 2 equals 10. You would multiply each side by 2 to solve that equation. Okay, and the last property is the division property of equality. Now, I said earlier, A, B, and C can be any number you want. In this one, it can't. C can't be 0. We're never allowed to divide by 0. Okay, so if A is equal to B, then you're allowed to divide both sides of that equation by the same number. It's called the division property of equality. Okay, all of these properties are in your book. So as we go through geometry, we're going to learn a lot of properties and a lot of theorems. It's up to you how many of them you want to take down and put in your notes. Okay, you need to know them. But I'll generally reference the page that they're on too. So if you can't copy down the entire property that's in your textbook during class, at least you know the page it's on, and you can go back and look at it. Because we might not always have enough time to just copy it down. Okay, but these are all on page 896. Okay, they're all on page 96. Okay, another property is called the reflexive property. And basically, the reflexive property just means something is equal to itself. It's like saying 5 equals 5. That's the reflexive property. Okay, and a lot of times when we study reflexive, there's 2 other properties that always go with it. Symmetric and transitive. You always see those 3 together. These are also all on page 96. Okay, transitive property. Okay, hopefully you've seen this one before too. If A equals B and B equals C, then A equals C. It's kind of like the law of syllogism. A little bit. Okay, another one you've probably seen is the symmetric property. Okay, if A is the same as B, then B is the same as A. So when you're solving an equation, some people get the answer like this, 2 equals x. They don't like to leave it that way, so they switch it to x equals 2. That's fine. That's the symmetric property. And the last one is the substitution property. So substitution basically means you're allowed to replace something with something else. So if A is the same as B, then A can be substituted for B in any equation or expression. Okay, when would you use substitution? In Algebra 1, you use it a lot when you're solving a system of equations. Y equals 3x. Y plus 2x equals 10. And I asked you to solve this system. Well, a lot of times you use substitution. If y is equal to 3x, we're going to take 3x, and we're going to change all our y's to 3x's. And in this case, we'd say 3x plus 2x equals 10, and then we'd solve it from there. Okay, that's one example where you'd use substitution. Okay. Any properties there that people haven't seen before? Anything there that was brand new? Okay, so most of those properties everyone should be familiar with. Okay, so let's try our first algebraic proof. Okay, so we're going to start off with the equation 5x minus 18 equals 3x plus 2. And we're going to write a reason for each step that we do in the proof. All the reasons are going to be properties from the other page I just gave you. First thing you often do when you start off with a proof is you write down what was given. Sometimes you have a lot of things that are given. Okay? But generally, one of the first steps in a proof is to write down one or more of the things that were given. In this equation, I'm just given 5x minus 18 equals 3x plus 2. That's the problem they started me off with. It was given. Okay, what would be my next step in solving this equation? There's many ways you could do it. But yeah, Connor?
You could either subtract 2 and subtract 5, or you could add 18 and subtract 3x.
Yeah, let's do it that way. Let's add 18, and in fact, I'll do what you said in 2 steps. Let's add 18 to both sides. So now we get 5x equals 3x plus 20. What's the reason that allows us to go to step 2? What property did I just use to do that? No, I didn't multiply both sides by a number here. Yeah, I added. This is the addition property. So I'll let you abbreviate it like that, of equality. That's the full name of the property. It's the addition property of equality. Okay, and Connor, you said, what was my next step?
Subtract 3x.
Okay, so subtract 3x. Good. So we get 2x equals 20. Somebody different, tell me what's the reason I can do step 3. Kira? Yeah, this is the subtraction property of equality. Sometimes I spell out subtract a little bit more, because if you put SUB, you might think substitution. So it's the subtraction property of equality. Okay. And there's one step left to finish solving this equation. Luke?
You divide 20 by 2.
Yes. Divide each side by 2. We get x equals 10. And can you give me the reason for that property?
That's the division property.
Good. Okay, so you guys nailed the reasons. That's good. That's the important part here, the reasons. Okay, because when you're writing a proof, that's the toughest thing to come up with. So this is the division property of equality. Not sure if you're going to see those kind of abbreviations in your book, but I'm fine if you do that. Okay, so there's an algebraic proof. Put your statements in one column, put your reasons in another, and then you explain at each step why you did what you did. Okay. Very similar kind of problem again. This one says 55z minus 3 times in parentheses 9z plus 12 equals negative 64. So we want to solve the equation, write a reason for each step.
Is that plus 12?
That's plus 12, yep. Okay, first statement I've written down is what was given to me. Okay, that's what I'm starting off with. What my given was. Okay, what would be my next step? And this might be a reason we didn't formally define with all the properties, but it is a property that happens in algebra quite a bit. Kiera? Yeah, what are you going to distribute?
3.
Yep.
And 9.
You're going to distribute that negative 3 and get negative 27
And negative 36.
z, yeah, and then negative 36. Do we distribute it to the negative 64? No, that's the other side. And the reason, that's the distributive property. Again, not a property we talked about on the other page, but it is one you need to know. Okay, the next step. What would you do with these z's? 55z, take away 27. Sarah? Yeah, we just subtract them. And what's that called when we did that? There's a name for it. Actually, this isn't a property I mentioned either, but this is, yeah. Yeah, you combine like terms, or you could just say you simplified it. That's the reason there. So you get 28z. 28z minus 36 equals negative 64. So either way, Katrina said combine like terms, or you could just say, in fact, let's do it that way. Combine like terms. All right, now we got 2 steps left. Okay, Nick, what would be my next step?
You add 36 on each side.
Good. Add 36 on each side. So that cancels out. We have negative 64 plus 36. It gives me negative 28. Ian, what's the name of that property?
The addition property.
Yep, addition property. Good. Addition property of equality. And now we just have 1 step left. Jacob, what would be my last step? Divide by 28 on each side. What's the name of that property? Well, look at the one we did for the reason for step 4. It's almost the same thing, except we're not using addition.
Division property of equality.
Yep, that's your division property of equality. Okay, so there's another proof using all reasons from algebra. Any questions on that? Does anyone think they need to do another one where you're solving an equation and writing a reason for each step? I don't know if you're okay with those. This one's actually a little shorter too. Okay, but same idea as this other two. Okay, some of the properties of equality that we just did with algebra, they're also used in geometry. Okay, the idea of the reflexive property. Something equals itself. Well, we can say that with segment length. The length of AB equals the length of AB. Or the measure of angle A equals the measure of angle A. Something equals itself. So we're going to look at the reflexive, symmetric, and transitive with how they apply to segments and angles. Why didn't I use the congruence symbol between AB equals AB? I need equals. Congruence would be wrong.
Because the length, we're only doing the measure.
Right, when you're talking about a measure, measure is a number, you always use equal signs with numbers. Okay, we're talking about equality, so we're talking about numbers, not congruence. Here's the symmetric property. Symmetric property says you can basically switch what's on each side of your equation. So, if the length of AB equals CD, then CD equals AB. Or in terms of an angle, if the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. That's your symmetric property. And what's the last one that we usually see when we see reflexive symmetric? Dakota? What's that third one? It's like a chain of things happening. Not symbolic. A good guess, but yeah. Transitive. Transitive property. Okay, so the transitive is when you have a minimum of two things leading to a third conclusion. So if AB and CD are the same length, and CD and EF are the same length, then AB and EF are the same length. Right? Same idea with angles. If the measure of angle A equals angle B, and the measure of angle B equals the measure of angle C, then A and C are also the same measure. Okay, these properties are all on the top of page 98. And we can also use the other properties of equality with segments as well. You can use the addition property of equality with segments if you add the same segment to both sides of an equation, or segment measure. Okay, and we'll try that in a little bit. Any questions on these three properties for segments and for angles? Okay, anybody still copying down? Yeah. Okay, so here's a proof that's a little bit more geometric. I'm going to tell you that AB and CD are the same length. Okay, that's given. I want you to show or prove to me that AC and BD are the same length. Okay, I'll give you a few hints as we go through it, because this is our first real proof that we're doing in geometry. Let's take a look at it. Okay, so first thing you want to do is put down your column for your statements. Put a line, put your column for your reasons. What's generally our first statement? We always start out with, generally, with what?
The given.
Yeah, what was given. We're given that A, B, and C, D are the same length. So we can write that as a statement. And the reason? They gave it to us. From here, we have to figure out everything else. And I'll kind of lead you through this one, and it's going to seem very easy when I'm leading you through it. You're going to be like, oh yeah, that all makes sense, everything he's saying. The tricky part is going to be figuring out on your own how to do it, okay? Because you don't really know all the steps yet. All right, so my goal here is to show that AC and BD are the same, somehow. So looking at that, I'm like, okay, here's, I'm going to erase this in a second, but here's AC. That's that part. And what do they want? BD. That's that part. Both of those kind of overlap somewhere. And they both involve what segment? Yep.
BC.
Yeah, they both involve segment BC. So somewhere in this proof, BC is probably going to start to pop up. Okay. In fact, that's what I'm going to start out with. I'm going to start by taking what was given, and I'm going to add BC to both sides of it. Okay. And let's watch what happens. So we have AB plus BC equals, I'm going to do the same thing on the other side. CD plus BC. Why can I do that? What property did I really just use? Yeah?
The addition property.
Yeah, the addition property of equality. I just added the same thing to both sides. So that's fine. At this point, we don't know if that helps us prove what we want to prove, but it's fine to try it. So it's the addition property of equality. Any question on that? Okay, now I want you to look at the left side and the right side separately. Look at AB plus BC in the picture. What is AB plus BC? We could rename that. Luke?
Line segment AC.
That's AC. And there's a reason for that, which we talked about very early on. That part plus that part equals the whole thing. Okay, so let's write that down. AB plus BC equals AC. Does anybody remember the name of that? When you add two parts of segments together to get the whole? Yep.
Segment addition postulate.
Very good. Segment addition postulate. Okay, that's the segment addition postulate. Well, if I did it once, I can also do it again. Look at the other side. CD plus BC. CD plus BC.
Couldn't you do it the other way around also?
Yeah, you could have done this other side first. Yeah, there's a couple ways you could do it. So in this case, what is CD? Yeah, in fact, it might even make more sense to say it that way. You're taking CD plus BC.
BC plus CD equals BD.
Yeah, perfect. Those add up to BD. Good. Everyone see why CD plus BC gives you BD? Okay. What's the reason for step 4?
Same as step 3.
Yeah, same as step 3. So I'll just write that again. Segment addition postulate. Okay, now we're pretty much done. Okay, we've almost proven what we want to prove. I can now say that AC is equal to BD. That's what they wanted me to show. But the question is why? Anybody see the reason why? And this is a property that I explained today. Yep?
Because if AB plus BC equals AC and CD plus BC equals BD, and both the same measurements, then AC has to equal BD.
Okay, so everything you're saying is perfect. We just need the formal reason why what he's saying is right. So he's saying, we know this and that are exactly the same. We showed that in step 3. We know this, and we know that are exactly the same. We showed that in step 4. So now we can say AC equals BD because of, Dendra? Not quite. This one's not transitive. But Kiera?
Substitution.
Yes, this is substitution. Okay. Fill in that right there. Fill in that right there. And you have AC equals BD. You did substitution. Just make sure I know it's substitution and not subtraction. Be careful how you abbreviate that. So I just spell it out. Substitution property. Okay, that one was a little bit tough. Okay, it all started with this first step of adding BC to both sides. How would you know how to do that? Or even why you would do that?
Maybe trial and error.
Yep, it's trial and error. You just learn from experience how to do it. There's no better way I can explain it. But now that I've done it, I hope it makes sense once you look at it. Okay, any question on that? All right. Okay, so let's take a look. This will probably be our last one, we'll see. But it says the Talladega racetrack has 4 turns that are banked at a certain angle. Okay, we'll call the turns 1, 2, 3, 4. And then the measure of angle 1, that's the bank in turn 1. The measure of angle 2, that's the bank in turn 2. And they give us a whole bunch of facts. They say that if you add up the first 2 angles, it's 66 degrees. If you add up the first 3 angles, it's 99 degrees. And they tell us turn 1 and turn 3 have the same angle. And turn 1 and turn 4 have the same angle. So the question is, find the measure of angle 4. Okay, find the measure of angle 4. I'm going to help you out with some of the steps. And they did that in this problem too. They're more interested in you giving the reasons. Okay? Because there's like 6 or so steps. There's quite a few steps. Generally though, what's a good thing to always start off with? The given. Okay? We have a lot of things that were given. We don't want to just throw everything up there that was given right away. We want to put it up there as we need it. Okay? So I think there's something we can figure out using the first 2 steps. I'm not sure if you see it yet, but if you know angle 1 and 2 is 66, and you know 1, 2, and 3 are 99, we can figure something out about angle 3. Okay? So we're going to write down the steps to figure that out, and then we'll get it. Okay, so let's write down the first thing that was given. Measure of angle 1 plus measure of angle 2 equals 66. What's the reason why I can say that? It's given. Good. Okay, let's say the next thing that was given. Or sometimes people will combine 2 givens into one statement. They'll say this, and they'll say the next statement. And it'll just be one big statement, and it's all given. To start, I'll break it apart into 2 for you. Okay, measure of angle 1 plus measure of angle 2 plus measure of angle 3 is 99. Okay, why is that true? That's given. Okay, what property could I use next? We used this property in the last problem too. Sometimes it helps to think about what we're trying to figure out. What do you think in step 4 I'm going to figure out? Anyone see where we're kind of going with this? Yep.
The measure of angle 3.
We're going to know the measure of angle 3 pretty soon. So the question is, step 3 is going to be the equation that would give me the measure of angle 3. So which property could I use? Connor?
Substitution.
Perfect. Substitution. You have the measure of angle 1 plus the measure of angle 2. We have the measure of angle 1 plus the measure of angle 2 right there. We're going to change what's in the red box in step 2 to 66. Okay, that's substitution. So 66 plus the measure of angle 3 equals 99. And the reason was substitution. Just the substitution property. There's no of equality there. Just substitution property. All right, now step 4. We can get the measure of angle 3. What can I do on both sides to get the measure of angle 3? How about Brian?
Subtract 66 from 99.
Good. Subtract 66. And somebody else tell me, well, Owen, what's the name of that property?
Subtraction.
A little bit more. Subtraction.
Of equality.
Subtraction property of equality. Good. Subtraction property of equality. Make sure you write it that way on the test. Okay, now as far as arithmetic and algebra go here, I think we're done with that. Now we've still got some more statements that were given. Okay, let's go back up and look at those and see if they'll help us. Okay, look, we know something about the measure of angle 3. We're also given something about the measure of angle 3. Okay, what statement? And actually, I think I'm going to say two things. We'll list two things in the same given here to save some space.
Well, and angle 3 equals 33 degrees, and angle 3 is also equal to angle 1.
Okay, we need to state that first.
Yeah.
So before we can use that fact, we have to state it in the proof. Measure of angle 3 equals measure of angle 1. Perfect. Is there anything else I can state while I'm here at the same time?
Yeah.
Measure of angle 3 equals measure of angle 1, and
The measure of angle 1 is equal to 33 degrees. We did the math.
yep, we've already stated that.
Oh,
There's one more thing we should state that I think we're going to use.
measure of angle 4 is equal to measure of angle 1.
Yeah, state the other one. Measure of angle 1 equals measure of angle 4. You can't use those facts in this proof till you say them. Okay? So let's just squeeze it in here. Measure of angle 1 equals measure of angle 4. What's the reason for both of those?
They're given.
They're both given. And this time I just decided to put them in the same statement. Save a little space. Okay, so I don't think we're going to directly use statement 4 yet. But let's do something with statement 5. What conclusion can we come up with from statement 5? Measure of angle 3 equals measure of angle 1, and the measure of angle 1 equals the measure of angle 4. So what can we say, Denver?
Measure of angle 4 is 33 degrees.
We can't say that yet. There's a step in between we have to say first. So you just have to tell me what you were thinking to figure that out, and that's the step.
Measure of angle 3 equals measure of angle 4.
Perfect. Measure of angle 3 equals measure of angle 4. I know this is kind of weird to write it this way, but this is what a proof is, right? And when we start doing like geometric proofs with triangles,
Wait, so you can do the substitution property of like measure of angle 1 is equal to 33 degrees. You couldn't do that?
substitution?
Yeah.
Yeah, we are going to use that, I think, in the end. Yeah. We just have to say a reason for this statement first. Okay, what's the reason for that? That's, yeah, transitive. That's the transitive property. Of equality. Okay, now we know the measure of angle 3 equals the measure of angle 4. And the whole goal of this problem is to find the measure of angle 4. But we know the measure of angle 3. So I can take and put that in for that. What property is that? Ariel?
So multiplication.
So multiplication is when you multiply the same number on both sides of an equation. This time we're not multiplying, we're changing something we have here with something else. I don't like to use the word changing, there's a better word, but that's the answer to my question. Owen?
Would it be substitution?
You're substituting, yes. You're substituting in what you figured out in step 4 for measure of angle 3. And by doing that, you've answered the question. The measure of angle 4 is 33 degrees.
Is there a way you could actually do more steps?
Sure, when you're writing a proof, that's important that people understand there's many ways to do it. Okay, there's no one right answer. We generally try to write the proof as short as we can, right?
I didn't mind the 8 steps.
But yeah, sometimes you do it in a couple steps more, a couple steps less. Any way that we can prove it and justify each reason, that's perfectly fine. Okay, so if you had a little trouble with all those steps, don't get discouraged about it. I'm going to be honest, proofs are tough. Okay, they take a while to get used to, and they take months and months to really start to get good at. Okay, so this is just your first time seeing proofs, getting used to it a little bit. Any question on that proof? Okay. So we'll stop there. So for tonight on page 99, okay, I'd like you to do 1 through 3, 4 through 8, all, 11 to 29, just the odds, and number 30. And tonight for MCAS, let's see, we did up through 6, so let's do questions 7 through 9.